Today we are going to continue our discussion on factoring binomials and trinomials by identifying and factoring out the greatest common factor. We've spent the past few lessons talking about this, so we're just going to expand upon this a little bit in this lesson today. First, I'd like to talk about factoring a binomial that has two variables. As always, our first step is to find the greatest common factor. Remember, if the leading coefficient or the very first number in your expression is negative, then we need to factor out a negative. That first number has to be positive. So I'm going to go ahead and factor out a negative, and then identify the greatest common factor between 63 and 35. In order to do this, since those numbers are a little bit large, you may want to factor down the 63, listing all the prime factors. We have 3, 3, and 7. And factoring down 35, I have 5 times 7. So our greatest common factor is only a 7. That's the only thing that they share. So I'm going to take out a negative 7, and then I have to look at my variables. I have 2 b's in my first term and 3 in my second. So the most that I'm able to take out is only 2. So I'm going to take out a b to the second. I have 1 a in the first term and none in the second term. So I am not able to take out any a's. They do not have any in common. So this negative 7 b to the second power goes on the outside of my parentheses. And on the inside, I write what I have left. Taking a negative 7 out of my negative 63, I have a positive 9. I took out my b squared, so that's gone, and now I only have an a. Since I took out a negative, this negative 35 must become positive, and dividing by 7, I get a positive 5. I took out 2 b's from the 3 that I had here. So when I take out 2, I only have 1 left. So factoring out the greatest common factor, we end up with this expression. If you wanted to check your work, then you would take your factor on the outside and distribute it back in. What you should get is the exact same thing that we started with above. If you do not get that, then you made an error in your factoring. To the right, my first step is going to be to identify the greatest common factor. And again, since my leading coefficient is negative, I am going to make sure that I factor out a negative to make that number positive. My greatest common factor might be a little bit more easy to find if I actually factor down each of my numbers. 56 is going to be 2 times 2 times 2 times 7, and 49 is simply 7 times 7. Again, the only thing that these two have in common, just like before, is only a single 7. So I'm going to take out a 7 with that negative. Now moving on to my variables. Looking at the x's, I have 1 in the first term and 2 in the second term. So the most that I can take out is only a single x. Looking at the y's, I have 2 in my first term and 8 in my second term. Since one of them only has 2, even though the other has 8, the most I'm able to take out are 2 of the y's. So I have y to the second power. Now from here, I write my negative 7 x y to the second power on the outside of parentheses. When I factor that out of my first term, my negative 56 becomes a positive 8. I have one x, but I'm taking that x out as part of my greatest common factor. And I have 2 y's, but I'm taking both of those y's out as part of my greatest common factor. So all I have left from that first term is an 8. Moving on to the next term, my positive 49 is going to become a negative 7 when I take out that negative 7. I have two x's, and I'm taking out one of them, so I'm left with a single x. And for my y's, I have 8 y's, and I'm taking out 2 of them, so I have y to the 6th power. This final expression is the factored form of your original binomial. And again, if you wanted to check your answer, you may simply distribute this greatest common factor back in, and you should end with your original binomial. I'll do one more, and then I'll ask you to try the next few on your own. Step 1, I'm going to look for my greatest common factor. Looking at the coefficients, I need my greatest common factor to be negative, but other than that, these two have nothing in common. So I have a negative. Looking at my y's, I have y to the 3rd and y to the 4th. So the most y's I can take out are 3, so y to the 3rd power. And looking at my x's, I have 2 here and none in the second term, so I'm unable to take out any x's. So my greatest common factor is simply going to be negative y to the 3rd power. So I'm going to write this on the outside of my parentheses. And on the inside, I write what I have left. I took out the negative, but I still have a 7. I took out y to the 3rd completely, but I still have x to the 2nd. I took out my negative, making this positive. And I took out 3 y's, but I had 4, so that leaves me with 1. And this expression is the factored form of your original. Go ahead and take a moment to please pause the video and try the next 3 on your own. From your first, your greatest common factor should have been 3u squared v. And factoring that out, you should have been left with 7v squared minus 10u in the parentheses. Down to the left, your greatest common factor should have been 4x to the 3rd, y to the 4th. And factoring that out, from your first term, when you take out the 4x to the 3rd, y to the 4th, you should be left with x to the 2nd power, y, plus 1. To the right, when you factor out your greatest common factor of 8xy, you should be left with 5x to the 3rd minus 6 in parentheses. We are now going to apply these same concepts to trinomials. We go about it in a very similar manner. Step 1, we're going to find the greatest common factor of all the terms. So looking at all 3 of these terms, I need to determine what is the greatest common factor. It may be easiest to do if you list all the prime factors of each term. 49 is 7 times 7, while 28 is 2 times 2 times 7. And again, I have another 28, which is still 2 times 2 times 7. The factors that each of these all have in common are the 7s. All 3 of them share 1 7, so I'm going to take out a 7. Looking at my x's, I have 2 here, and 3 in my last term. Even though the last one has 3, the most I'm going to be able to take out are 2. Looking at my y's, I have 3 and then 2 and none. Since the last term has none, I am unable to take out any y's. So my greatest common factor is 7x squared. From my first term, when I divide my 49 by 7, I get 7. I have x squared, and I took out an x squared, so there's no more x's. And I didn't touch my y's, so I still have y to the 3rd. Factoring out a 7 from my negative 28 here in the middle, I end up with a negative 4. I factored out an x to the 2nd, so there's no more x's, but I did not touch my y, so I still have y to the 2nd. For my 28, I factored out a 7, leaving me with a positive 4. And I have 3 x's, but I took out 2, leaving me with simply 1x. And this is the factored form of your original expression. To the right, Your greatest common factor of these three should be an 8. I then have 1x, 2 x's in the second, and 7 in the third. So I can take out 1x. For my y's, I have 1, 1, and 3. So the most I can take out is only 1. On the outside of parentheses, I have 8xy, my greatest common factor. And on the inside, 40 becomes 5, and I took out both xy's. 48 becomes a positive 6. I only took out 1x, so I have 1 left. 16 becomes a positive 2. I took out 1x, leaving me with x to the 6th, and I took out 1y, leaving me with y to the 2nd power. So this expression is the factored form of your original. Go ahead and take a moment to please pause the video and try the next 3 on your own. Your greatest common factor for the first should be negative 5xy to the 2nd. Factoring that out, you should have 10x to the 4th y plus 9x to the 3rd plus 7y in parentheses. Down to the left, you should have negative 7mn as your greatest common factor. Factoring it out, you should have 6m to the 4th plus 7n to the 3rd minus 5. And last, your greatest common factor should have been a negative 4x to the 3rd y to the 3rd. Factoring that out, you should be left with 6y minus 3x plus 10 in parentheses. Now I'd like to go ahead and take a look at something that's a little bit different. However, we're going to go about these in a very similar manner. Looking at this expression, it's much different than what we had before. But let's say for a moment that I had x times y plus 5 times y. So this whole thing, what I'm going to do is simply rewrite it as y just for a moment so we can see what we're going to do. Well, now you can see, hey, I have a common factor of y, so let me factor that out. I have y on the outside with x plus 5 left on the inside of my parentheses. Well, now, down here, instead of a y, I have this entire binomial. That binomial is repeated twice. So I am going to call that my greatest common factor and factor that out to the front. So I take out my x plus 2's to the front, and what I have left after I factor that out, so that is now gone, I have an x, so in parentheses, x from the first term plus 5 from the second. To the right, I see an x plus 5 repeated. So I am going to factor that out as my greatest common factor. I factor that entire x plus 5 out, keeping it in parentheses. And once that is gone, in my second set of parentheses, I have a 3x plus 1. Below to the left, I see x minus 6 repeated. So I'm going to factor that out as my greatest common factor. In parentheses, x minus 6. And in my second parentheses, when I remove that x minus 6, I have an x plus 3. Again to the right, I see x plus 4 repeated twice, so I'm going to factor that out as my greatest common factor. When I factor that out in parentheses on the front, what's left in my second set of parentheses is 2x minus 3. So let's go ahead and recall for a moment our process of distribution. What we have done in the past is taken this entire x minus 1 and distributed it to both terms inside the second parentheses, giving us x times x minus 1 plus 3 times x minus 1. Well, now all we're going to do is rewind that process and do it in reverse. Instead of putting the x minus 1 in, I am going to take that x minus 1 out since it's repeated. So I end up with x minus 1, and when I take that out, I have x plus 3 left in parentheses. Go ahead and take a moment to pause the video and try these next 4 on your own. Go ahead and check your answers, and I hope you enjoy the rest of your day.